at 2.5 million bits per second, coming straight at you. This is stream number 46. So taking my parser libraries, wrapping them in Lua, doing weird stuff like making boxes with limited lifetimes. I was looking at this thinking maybe that's not the best lifetime name. Then again, I did name the structure that. I think at one point I called this class ingestion. I wonder if that would have been a better name for this. I am exporting it as ingestion. Something to consider when I'm refactoring. What is this? I have an error? What? Oh, right. I was in the middle of, I guess I had started refactoring that. Yeah, I had changed that to not borrow it. I shouldn't do that. The end of a stream breaks something like that. I got 42 warnings I should fix before I move on. Not using table. Not using error callback or ingestion args yet. Oh, well, this was only while we were trying to fix something, right? Now that it's fixed, I should be able to do this. Closing that should get rid of all those warnings. There we go. Why is it still parsing that? I told it not to parse that. Hold on. Do I have to restart the server? So for the parser source, for the module, there should be a don't to allow all warnings. I guess as long as I don't open it, we're fine. Don't open that. Okay, component, right? So I guess I should have this be driven by what we want to do in the Lua, right? If we want to have like this is actually a part, and that's the part. This is actually a path, not a name. If the goal is to print width 300, height 300, then there's two things. We need to have a wrapper for the part and be able to access its value through the index. Okay, I have data component, but it's empty. Oh, it's like this right now. Okay, we want to implement the we want to implement from Lua for that, right? This thing. For data component. Why does it think it's a cell? Oh, I think it's because this has to be marked derive clone. Okay, that's it. I call that Lua error. It doesn't know how to import it, but if I import it as mlua error, I think I'm going to change that to Lua error because error I think is too ambiguous. I think same thing for value. I think I'm going to call it Lua value. Let me go do that for all of these. Well, don't have a problem with that one. Lua value, Lua error. Okay, we're getting there. Slowly, but surely. Lua value, error as Lua error. Huh. Okay. Looking good, looking good. All right then. So it goes back to that ingestion callback, right? If this is going to not return the value, but actually return the part. If I'm constructing a component for that part, dot clone, that error is now solvable if I do a RC here, right? And this thing already takes an RC, but the whole thing doesn't have the right type. So then I have to go back and update this type to take an RC here. Okay, but then that leads to mismatch type here. If I change this to an RC, then I have to change this one also. Yeah, so all the errors are going to like propagate now. So since that's an RC, this has to be an RC. Actually, this one, maybe I can do an RC new on this one because we own it, right? This one though, we got it from the caller. So what calls ingest? That's main program, so I don't care about that one. This is the bridge. Okay, that could be owned also. And this one, tests. Okay, evaluate function. See, they're all take a new one, so I think maybe I can have this one be owned. So composite RC new composite. New with part. At what point does stuff added? Add part, right? So that's going to be an RC probably eventually. Ingest composite's probably going to return. It is already returning an RC. So yeah, that's why there's an error here. Okay, I think we're good. This can be this could take an owned one and turn it into a RC new. So this is already an RC at this point. So this has to return an RC. Okay, and so here part has to be an RC. It already is. Well, keyed children needs to be an RC also. Which leads to more errors. Iterations has to be, no, part iteration has to be option RC component. So this is RC new. Adding a part. Yes, so might as well package it up here. Hold on. Maybe it should already be a RC by the time it goes in here. Not that one, but this one, right? The part here is okay, yeah. If I say that this is an RC new, right? That fixes that error there. But then we have this error, but if this just takes an RC, that'll solve that. Okay. So yeah, RC new, whenever we're inserting something new. RC here. Finalist components. RC. Okay, so map or. So this. This one should take an RC. Mutable. Hold on. This is a different kind of implementation, right? So RC. Can I not do that? Ah. I guess the way this is done is self is a RC self. I forget this syntax. Is it on the right here? Yes. Okay. Two errors. Now we're up to 36 errors. Oh, RC doesn't allow us to mutate it, does it? Yeah. So maybe this can't be an RC until it's, well, hold on. Yeah, okay, that's a problem. We can't start sharing references to it until we're done constructing it, unless I put them in cells. Hey there, Ivan, the Raging Python and Nightshade Dude. Yeah, okay. Well, when I put it into RC, it becomes immutable unless I put it into a ref cell also, which is a real pain in the butt. Same thing with keyed children, right? We're collecting them, but that's also we also want to continue to update them. In data component, new functions just return an RC data component. They could, but then that makes them immediately immutable. I'd have the same problem I'm having now. If they're owned, we can mutate them. The moment I put into an RC, it's immutable. So I kind of wanted to delay putting them into an RC until they need to be shared. Problem is that we're sharing them almost immediately with the part callbacks. So I think there's no way around it. I gotta like put them in a ref cell. So what if I make a convenient type for that? A shared component. RC ref cell component. I can't do that now. Then it's going to be a self again. And we'll have to borrow before we get into here. So this, yeah, this will have to iteration dot borrow mute dot extract value. All right. Okay, so borrow mute, because actually I can do that, right? And then it becomes a mutable component because we have mutable access already. And this can just take a component now. No, that might be shared already, right? Which means I don't want to do that. Hold on. Did I misspell it? Or it's not public or something? Oh, shared component. Okay. So I need to import that in a weird way. All right. I guess it's at the crate level. Yeah, here we go. Wait, what's wrong with this one? Unresolved import. Oh, because in data we have to do it too. Okay, so that's good, and then that makes this good as long as I import it. Okay. How many times do we use part here? Okay, so that should be a borrow. All right. House smelled good because you made bread. Love bread makers? Cool. We're gonna be doing this a lot, right? I have an idea. What if I make a method of decouple called wrap? Can put it at the end. That's fine. Self shared component. RC new ref cell new self. There. Now I don't have to do all that new stuff. I can just do wrap. Name it share. It's not a bad idea. Not a bad idea. So points for get off my lawn. Get off my lawn, you damn kids. Ugh, how come I can't navigate worth crap this morning? Share. There. That's what I wanted to look at. There is shared. Okay. I actually don't need it to be mutable anymore, do I? I also don't need this to be mutable. No, I do need that one to be mutable because that's oh no, it's not. It's just get. Optional shared data component. See, this one is again the share, right? So I can hear, well, this is in a loop, right? Yeah, so I have to borrow. Borrow, borrow, borrow. Actually, this is the only immutable borrow. These are mutable borrows. And this is share. Okay. Borrow, borrow mute. And yeah. What would I do without the Rust formatter? Borrow mute. Only 74 errors to go. 73. Child. We don't, oh, there it is. Part. So this is shared. Borrow mute. Because we won't borrow again from composite, right? We better not. Okay. Same thing here, right? There's local child entry. I'm trying to see from this. It's hard to see from this type because I'm not don't use the entry type too much, but it does need. I guess it depends on how it's used. We might need mutable access to this. Yeah, because well, insert needs mutable access. Okay, so we need a borrow mute then. If I did borrow, I would have a problem here, right? Not here. How is that possible? The moment I do entry, which is mutable, looks like it's mutable, yeah. Isn't it going to have a problem if this is just borrow? Let's leave that in. I want to make sure that we get an error there. Sometimes the compiler won't show us all of our errors. Same thing with this one, right? It shouldn't let me borrow to remove. Should. Bothers me that it's not giving me an error right away. These are all immutable. Yeah, so like it shouldn't. I'm just gonna fill it in here. It should require mutable access to the thing. Mm. We're doing sure doing a lot of borrowing, aren't we? Okay, here's that callback, right? So this should take a shared data component. You know, I'm fixing errors, but the error count keeps going up. It's very scary. For this whole thing, I could do let data equals data dot share, right? Or borrow. RC does the runtime borrow checker. You heard? Yeah, but you have to do borrow mute if you want a mutable access. Just do global find and replace from dot to borrow. Yeah, right. That'll fix everything. That'll overfix it. Oh, wait, I don't need to borrow this. I can unpack it. What was that? Like get mute? Because that's on self. It won't let me do that. But Okay, yeah, there's no way for us to know that it's not shared anymore, and I can do that. So maybe, I guess I have to clone it, which is unfortunate. Is this, it returns a shared data component, not an owned one. It has to return a shared one because it's part of injustice common. No, not part of that. It's part of, actually, hold on. Maybe it can be owned at this point. Maybe I'm being too aggressive in returning a shared. Maybe it doesn't need to be shared yet. It's only when it's stored does it need to be shared, or if we do the callback. So actually, that's right here that we do it, right? Yeah, at this point, Lua could hold out reference to it, so it has to be shared on the way out. So yeah, if it's hard to, it's gonna be. Let's see if I can get. This is not gonna give me an error yet, but I should get an error here, and I think I'll have to clone. Lots of borrows. Iterations on vector. Kitty cat wants in. Hey there, Brooke Zerker. Say hello to my cat. Now she wants to go feast. Did you raid while it was a momentary chair stream? So much purr, yeah. She's like, "You let me in, I will purr for you, and then I will go consume cat food." I'm in the middle of doing horrible things to data structures. So I realized that I want to share values of this type. So made a type called shared component, which is rcrefcell, because we want to do two things. We want to be able to share them, and we want to be able to modify them after we share them. So you have to use the evil combination. So I'm putting all shared references to this thing, or making all references to things that need to be shared. Now I have like a gazillion errors that I'm having to resolve. Who's Zilby? Just left, right when you press the. Oh, is that your cat? We could have had a cat seeing another cat on the screen. It would have been a catastrophe. What's the dog doing in here now? What you doing in here? Hello? Hi, puppy. Just staring at me. All right. Anyway, I got 90 errors to fix. Is your orange cat? I'll see your boss. What, you need something? Do you need to let me let out? Hold on a sec. So when we're having these ones out, she stands or sits at the doorway and goes, "Whoa, whoa." And that's like, let me out, human. I need to go pee. Okay, I was looking at this, right? And thinking, does this have to be shared? I think the answer is no. So I can just do a borrow here. Hold on. We can't borrow it? Why not? Oh, borrow get. Into? How do we get a borrow? I thought you could do like a get on one of these guys, one of these refs. Could you get a normal reference? Oh, I think the answer is no. You can't get a normal reference because then you might share it and it's not counted anymore. Well, then why don't I just change it so that it's a shared data component? It's just now I'm gonna have to borrow. Oh, she wants back in now. All right. Borrow. Borrow. My cat's okay with the closed door. She's got this weird thing where she wants you to be around when she eats, and she'll only eat like in like small periods of time. So like she'll eat a little bit, she'll leave, she'll come back, she'll eat a little bit more, she'll leave, she'll come back, she'll eat a little bit more. And each time she bugs me, she's like, "Hey, come over here. I want to eat. Come over here. I want to eat. I want to eat, so come over here and pet me." Can you just rebar to get a normal reference? I don't think you can, because then you could break the rules of the because borrow gives you like a guard that when it's an RAII type, right? So when the ref is out of scope, it knows that you're no longer borrowing it. But if you were able to get a shared reference, you could then you could violate that RAII, I think. I could be wrong. Maybe you're onto something. So let's see, can I? So that we're back to this. Can I borrow and then reborrow? Maybe, huh? Maybe you're right. Oh, but then we have to walk. Well, can I do the same trick here? Oh, okay. I was wrong. Japo, you get a point. Now you have 11. So we can reborrow to get... I guess what that does is it locks down the borrow now into a compile time thing, and the borrow checker knows that it now establishes a lifetime for the borrow, whereas this is sort of a runtime lifetime. If you ever need to borrow mute while reborrowing, you'll be in trouble. Yeah, that makes sense. Reference to difference is breaking your JavaScript brain. The problem is that this is not an actual borrow. It's a ref RAII type. It's an object that contains a borrow inside of it. There's the actual borrow, right? And it's one of these weird things where it's a cell and yeah. And they use a pointer instead of an actual borrow. So they talk about that right there. So if you actually need it to be an actual borrow like this, you have to first dereference it to get to the thing we're borrowing and then borrow a reference to it, which is, at first I didn't think that it would let me do that because I thought that the dereference would be now like it's a temporary object. But yeah, it's not, right? The rules of this ref are that you can dereference it to get to the T. If you can get to the T, actually, I think that's where it is. Dereference gives you the borrow, but then you should be able to get a reference again. It's actually a place, which is the rest equivalent of an L value. Yeah. That's why we need to do this reborrow. It's like saying that we're going to actually access the thing that we're borrowing in order to borrow it again. Get a traditional borrow, a compile time borrow. So yeah, that's a compile time borrow. That's a runtime borrow for a cell, a ref cell. Okay. So we need mutable access to this because we are doing that stuff. So borrow mute. Borrow. Okay, so this we made a little helper called share. Part. Ah. Well, this is just shared now, right? And then part. Can't we just clone it? Get a reference, right? I don't need an into mute then, right? Don't I just do a get? Entry is an occupied entry, right? How do I guess I have to dereference it? Yes. Dereference the entry? Yep, I'm learning. Okay, value ref is yeah, we have to borrow mutably the value. There we go. Part isn't mute. Well, part is it's inside a cell, so we have to get it. We have to break into the cell, borrow the value mutably. So that's to be a borrow mute. Yeah, my code's getting like more convoluted. The more we have to deal with the cell, right? So like, why do I get the feeling that I'm going down the road to ruin with this? It's fine. It'll be fine. Execute keep statement. So borrow mute. This is just a borrow. And this is a share. It's all fine. We're on down to 74 errors. It'll be fine. Okay, this should be that share. Okay, we're getting there. $70 errors. Only 70 errors. Callback hell in JS. Now we have borrow hell in Rust. Yeah, it's because really I want to do the same thing that I did my C++ implementation, which was, if I can show you, how come there's no component.cpp? Is it data component? This thing. Yeah, it's that I use standard shared pointer, right? So the closest equivalent to that in Rust is an RC ref cell or an ARC mutex if you want it to be thread safe, right? So that's just the nature of the structure that I'm building. I want to be able to like share pieces of it. So we have to like opt into all of this like, you know, separation from the borrow checker saying, hey, we will do it at runtime, not at compile time. Wait, what? I see. So I should just do a match on this, right? Yes. Those darn temporaries. Same thing here, right? It looks like I should just borrow this for the whole scope of the statement. Borrow mutably. So this just becomes composite. What? What? Oh wait, that's gonna be a problem because of this. It's what is it trying to tell me here? Yeah, okay, so we can't do that. So I have to think through this. So we're gonna borrow self again. So we have to temporarily get to the origin. We're using the origin there and there. This is all to compute the boundary, right? And then I borrow it again down there. That's fine. So really we'll just say let boundary equal let composite equal self composite borrow. Then use composite here. And then turn that into that. Does not live long enough. It's dropped. Why is it still being borrowed? It's just a U size. I don't get it. Do I have to say like let boundary equal boundary? Yes, I do for some reason, even though we were just dealing in U sizes there. Weird. I'm okay with that. So what's wrong with this one then? Oh, is it the same thing? So then what are we computing here? Original, well, we're going to use self again here to do a warning. Erg. Really, we're just getting there to get this offset, right? So I should just put all of this here. No, well, but then I was using the origin twice. Get the origin, get the offset out of that. And then I was going to, well, actually, yeah, I need a mutable borrow anyway. Let's see if I can get myself into trouble here. Oh, it was actually okay with that until it got down to here. So then why don't I just say let original boundary equal this whole mess. Because I have to say original boundary. Oh, it's up here. So I don't need to do any of this. I can just bind, I could put a, I can just do that. Just make a block. So the block limits the scope of the borrow to these statements so that I'm not borrowing it when I need to do a mutable access to self. I guess it lets me call on warning on self because we don't need a mutable access to self to borrow mutably from the cell. That's why I was able to get away with that. Okay. Well, we snuck our way past that one. I have a feeling I'm going to have a whole bunch of other drop temporaries. Yeah. Shoot. Oh, man. This is painful. Well, let's see if I do this composite. What kind of trouble I can get into here. Cannot mutate immutable variable. Mutate, please. The entry does not live long enough. Say what? It's dropped on line. What? What? Oh, because I want to do a clone, don't I? We want to get a reference out. What does insert do again? It gives us some access to the value so I can then clone it. Because really what we just want another reference to what we stored into the map, into the keyed children. Yes. It's another thing that doesn't live long enough. Mismatched types. Oh, right. We don't actually need to do an as mute. I just need to do a get. And then an expect turns it into a option. Why is it? Okay. Right. The expect means we, yeah, like it says, we failed to make room for it. And then I don't need an as mute. I just need to, I just need to expect again. We failed to fill component iteration. Oh, no, I do need to do an as ref. And then, actually, I need to clone it. There we go. Because it's a reference again. And parent needs to be mutable. It is mutable. Wait, why didn't it let me overwrite it? It's borrowed. Borrow occurs due to a deref coercion to a ref cell on that line. Oh, I see. Yeah, but once we clone it, we're done with that borrow, right? So how about I do child, parent equals child. There we go. Got around it. Oh. So I think I have to do oh yeah. It can't be an option. How was this structured an hour ago? I must have had a mutable reference to something. Was it get mute on the vector? Yes. And then you can assign to it, I guess. If it's out of bounds, hold on. How did that actually work? Oh, the slot is there, but there's nothing in it. So that's correct. How come it won't let me do it? Because this needs to be borrow mute. Okay, that was it. So we're borrowing the child slot. It's mutable, and then we can assign into it something. Okay. This same thing, right? We need to like, yeah, it says it should get an error here. Where are we borrowing it as mutable anyway? It's because entry is mutable, yeah. So we did indeed get an error there. Okay, and this has to be cloned, right? Oh, actually, we want to return an entry? Oh, that's a problem, right? We can't do that because we'd have to do a temporary borrow to get into here. Okay, I have to restructure this then, don't I? I should say like with entry, do some kind of closure. That's what I should do. With entry. Once. And it gets a mutable. What does entry give us? It just gives us a mutable shared data component, right? Okay, so it's just F. So there's no result, or I guess it's result. What's the string here? Oh, that's the error. Okay, never mind. Yeah, it's all through the side effect of calling the function now. So this would just be okay. But first we want to do f of entry. Entry, I think. Or do I need to like expects a mutable reference found an entry. So I'd have to like do a get mute. Oh wait, no. I know it. The original type this was. That's the type that should be there. Right? That should go here. Let it be consumed by the function. Okay, there we go. And so now this body has to go. Actually, that with the match has to go into here. Entry. So it's match entry. And this goes into there. Cannot borrow self is mutable because previous closure requires unique access. Oh, that's a problem. I guess I can plumb the return value out. Because I'm only using the entry to either insert a part or to assign a part. I can we're only doing this side effect if it's if we actually insert it. So we'll have it be dependent on some type where this function returns that type and the result is that type. And so we're returning that whatever the closure returned. Should be okay. I guess I could turn it into a result also. I could let the closure be fallible. Temporary value dropped. Sure. Let's hold on to it the whole time then. Ah, I only have one clipboard. And my data has been disintegrated. I know. Hey there, cat peasant. I'm trying to reintegrate my data. Mute. It still doesn't live long enough. Do I have to do something like where I have to let result equal that and then okay result? No, that didn't work either. It's still dropped at the end of the function. Why is it still borrowed? Lifetime call defined here. Argument requires that composite is borrowed for call. Oh, I don't want to borrow it for the whole call though. How do I tell it doesn't need to borrow it that long? Oh, because... But we called the function, right? Aren't we done with it at that point? We've given it the entry. It owns that. Okay, so it's this thing. So it's actually doesn't borrow it for as long as I thought. So there's actually 2 lifetimes. So call back. Where the call outlives the callback. Yeah, composite's borrowed for callback, but the call outlives that. Okay, I'm trying to teach it that entry is only borrowed for the callback lifetime, and the call outlives that. That wasn't enough to teach it that. I wish I would tell me why it thinks that it doesn't live long enough and that it's dropped while still borrowed. Can I just drop it here? Why can't I drop it there? It is borrowed. Borrow occurs on 172. Binding composite declared before. Argument requires that composite is borrowed for callback. Yeah, but that lifetime... It goes into the function. Okay, is it that the result lives let? Okay, I think it's that the result has to is bound to well, it's that callback call. I can't do that. Oh, the lifetime of R is call, right? Or callback. No. I could make it a concrete type. Shit. I don't know how to do this. It all if we don't return anything, then we don't have a problem, right? No, it's still a problem. It had nothing to do with the return value. What if I put this inside of a scope? It really doesn't like it. It's dropped. It thinks it's outliving the scope. I guess it's because I'm giving it to the function. What if I just let it borrow it mutably? It's it's funny. It's like I can't tell it that it's not borrowed anymore by the time like I put it into a scope. How did it escape? We're only letting it borrow that entry. What if I don't even call the function? Okay, it has to do with the function call, because if I don't call the function, it's okay with it. If I call the function, even though I'm saying, what if I just elide that lifetime? Okay, so if I let it figure it out, it's okay. So I probably don't need this anymore. Okay, so I don't know what lifetime to say to fix that. I'm doing something wrong with this. Do I need the call lifetime? I probably still need that. Let's see what happens if I get rid of it. No, I didn't need it. So I probably don't need this. And I can go back to having it plumb the return value back out. I have to do an R, right? Yeah, okay. Whatever. Let it elide it for me. That's fine. Yeah, this should be a bar. I mean, like it says, there should be an error there, and there is. Ah, man, so many errors. I spend all stream getting this fixed. Cannot move out. So here I definitely want to clone it, right? Because we're borrowing. Should get an error here. Yes, we do. Clone it. I don't want to have to clone it though, but the consequence of the fact that this one says that it might be shared with something else. So if it's shared, then we can't move it out. Refactor until Rust figures lifetimes. I wish I could have figured that out myself though. Like name it somehow, but yeah. I'm not good enough with Rust to like be able to figure that out. It's just that it doesn't live long enough. Yeah. I think that needs to be a mutable borrow. Actually, no, it doesn't. It's just getting it. I'm gonna want to clone it, aren't I? There we go. What's part again? Oh. Yeah. It's a borrow. Well, let's just clone it. When in doubt, clone it out. Part iteration. We're getting it. Cloned. What's wrong with that type? How come I can't do that? How'd the borrow occur? 34. Oh. Yeah, but I cloned it out. Okay, then we'll do it this way. If let some child equal child. There we go. I tricked it. Tricking the compiler. Oh, well, so much for that. Temporary value dropped. Yeah, we can't reborrow. And it doesn't make sense for us to borrow. And we should just borrow it in order to clone it. I'm dealing with references now, right? Reference counted pointers. So this should just be a shared data component, I think. Or should it? I think it needs to be, because here we're descending into its iterations. So I think that needs to be shared. So this is a problem, right? We can't just borrow from it like that. This sucks. It's 66 freedom degrees here. Only 51 freedom degrees outside. I have to get my brain around these shared references now. So this, okay, so the problem is that if we start to index into its value, which is a vector, now we're starting to borrow something through a shared reference. So I'm tempted to just hold on like this part and make that an actual just like a ref to a data component and not a cell. Problem is you can't get something through that ref and then drop the original ref. I have to hold on to the whole tree, which is a pain. How am I going to do this then? How are we going to descend into the value of the part? Unless I make the value also shared? Why is it going to that? Oh, because, yeah, go through that. If I make this value shared also, then that makes it a little bit easier. It also lets me, it also allows me not to have to clone it. So maybe I do that. Make this shared. Pub type shared value equals RC ref cell value. So then this becomes a shared data value, which I'm going to have the same problem, right? That data has to bring in a shared value. And then this has to pull out shared value as shared data value. Wow, this is because of this, like everything that uses values is going to have to like break into the cell. But then the one advantage of this is that I can wrap it in Lua a lot easier. So I probably would have needed to do this anyway. Yeah, so when we extract a value, this can be a shared data value. And clone now is much cheaper. Extract, wait. Why do we expect a value there? Oh, because vector needs to be of shared values. Yeah. Well, we're gonna need that anyway, right? And yeah, this is infecting. The sharing is infecting everything. Yep, sharing is infecting everything. Yep, because I gotta do this now. Too bad I can't call things in an interpolation context. Now I got 351 errors. Jeez. Okay. Blah, blah, blah. It's this thing, right? No? Oh, because of this extracted vector. Shared data value. So what's the deal with that? Oh, this. I guess we're making a share. That's interesting. It should have caught it. Oh, because there's a self there. Yeah, so one of these for data value. Where's the impl? Where's the impl? Where is the... Okay. There it is. Still doesn't like this collect. That is the correct type. Why doesn't it like the extract value. Why does it expect a value at that point? Oh, because of that. There. Same thing. Got to share a nil. Actually, we could just have one global nil at that point, right? Where is this called from? Maybe it should just be shared. Actual is, yeah. Should just overshare. So that's shared. Actually, let's just borrow it so we can say we just make our own reference to it. Or maybe not. Yeah, because why clone it if we'll just make the caller clone it if they have that if we have to. Like that. Wonder if this will slow down the code to be doing all this reference counting at the value and component levels. Now we're up to 339 errors. $336 errors. This should be shared. Okay. It's like the error count isn't really going down, is it? Now I'm looking like everything should be shared. The infection is spreading. Like, shouldn't that be shared too? Like, if that's not shared, that shouldn't be shared either. So what? So hold on, let me undo that. I undo that, then it doesn't like this. But if I say we're not sharing those, then, and we're not sharing it here, at some point we have to share them. Maybe it's in here, populate. I think it's right here. We got to do a share. Share. Sharing the value and sharing the component. Okay. Constructing a map, and because evaluate, wait, what's the problem here? Oh, it needs to be shared the moment it becomes a value. So that means I gotta share. Evaluate key value needs to actually give me shared values. Or does it? I think maybe not. I should at this point share it. So let key value equal key dot share value dot share. What? Oh, that, which means that this has to be okay. Okay. Same thing here, right? Only this one I can just do a map through shared data value share. Yeah, I'm gonna run out of time before I can fix up all this stuff. Evaluate function. This one I can borrow and then clone it, right? Although I think the whole point was not to do that. So actually, what happens to this component? I guess it just naturally falls away. So we clone the reference and then the data ceases to exist because it's not used. So I don't need to borrow the data value. I just clone the reference. Okay, so then we're really cloning the reference here. That means we're not cloning the data value. So that's a little bit better. We're moving it out through through moving a reference. Okay. Because I said it would be shared. Does it actually need to be shared? Well, it's shared because it's in the composite. So then how do I... It's possibly shared, right? So, ooh. I guess I have to clone it. So I have to borrow it and then clone it. I can't do that. Oh, because it's a result. Question mark. Yeah, I shouldn't have to borrow mutably. It wants a result? Okay, then. There we go. Still at three. It's like we're hanging at 330 errors. Yeah, we can't do this kind of thing anymore, right? So that needs a shared data component. So we would just part being a shared data component. We just clone it. Actually, do we even need to clone it? Can I just... I think I do need to clone it, right? If I just pass it, it's moving it out. It wants a value out, so we can't do that, right? This has to be shared. Okay. What? Oh, this value is, yeah, this actually generates data value. Okay, we'll fix that. This should be shared data value. Shared. Okay, so then this becomes a little bit easier, right? Because we can sum borrow the part to clone the value reference. Okay. So this should be like borrow. Get a reference and then dereference it. Yep. So then it's this because values is a vector of them. So I'm picking one out and then I'm cloning it. Okay, I'm getting through this very slowly. We're getting a key and then mapping it to clone. I guess that's cloned, right? Key is a value. So I have to share it? Sort of weird. Okay, anyway, moving on. Borrow. Borrow again. Not there. This should just be clone, not borrow clone. And value being a shared, right? This is some share nil. And then again, we're not doing that. We're cloning, borrowing the part to get to it. Okay. Yes, so we're not doing that. We're borrowing the part to get to the value and we're grabbing a reference. So we're cloning a reference. Then I haven't updated this. This should really be a shared data value, right? I think this should also be shared. Well, let's see if that needs to be. And the result should be, again, a shared data value. Okay, so we get back. Right, this should be a shared data value. Yeah, interior mutability. We no longer have to return mutable references. Same thing here and there. Okay, getting there. Still haven't really hit that error count much, have we? Okay, this would be walking the index path. We're borrowing, right? And then we're dereferencing it. And then this has to be shared. And then this is just cloning a reference out. Index. Okay, well, if index is a if we're just using that, okay, then this is easier said with a shared data value. And this has to be shared. Key values entry or insert. What's wrong with that? Why did it find a mutable reference? Oh, this has to be cloned again. Lots of sharing and borrowing and cloning, aren't we? Yeah, so I have to borrow to actually get the value to print it. Why did I make it owned data value? Shouldn't that just be borrowed? Try from. Wait, why is iSize try from take it not by reference? It's not copyable. So this just always consumed the value? Huh. Oh, I guess we dereference that because it doesn't really consume it. There, fixed it. And the same thing here, right? Borrow it. Yeah, because we don't need to consume it. Okay, so we're just borrowing it. Borrow. Okay, that's weird. But okay. Okay, we are okay, so walking an index does push, so we need to borrow mute. And hold on to a reference. I have to say I have to actually say cell ref mute value, don't I? I can do borrow mute dot get mute, right? Or borrow it mutably. Nope. Or can I do it this way? Yes, I can. This is really gross. Okay, so this really needs to give me a shared. So I need to evaluate them and then map them through data value share. What? Because it's an iterator of results. Wait, what? Oh, the map has to be internal. There. We're returning that, but Why does it think that indices is oh, because I told it was not shared. I think I can remove that constraint now, right? Yeah, that was just a temporary constraint. Okay, my hands are getting cold. It's so cold in here. Jeez. Okay. So this whole thing was to try to manufacture a new data value, and dereference gives us a shared data value. So I already did this borrow clone. Do I just want to make evaluate expression give me a shared data value? I don't think so. I think we should just continue to do an okay borrow clone. I don't like the fact that we're cloning data value though, whenever we get a reference. I think before though, reference, this dereference was cloning on its way out anyway, right? Copy the value. Yeah, we were already copying it. So we just moved it up, really. Actually, then is that used anywhere else? If it's only used there, wouldn't it be easier to just return a data value? Then yes, value will be a shared value, but then we can clone it on the way out here. So unwrap the option, or else we have to do that. I want to first map it. Map to clone it, and then I don't need, well, actually, if I do unwrap or else and then borrow and clone it. So I move this out then to here, and I do borrow clone. Yes. Oh, it's hard to wrap my brain around. No method name. So we don't need to do this anymore. This I took care of it. We just do that. We don't even need to do the question mark anymore. So maybe the same thing for evaluate function. So the idea is to like remove some of this unneeded stuff, right? So for it to return an owned data value, I want to borrow from here, right? Borrow it and in order to clone it. Yes. Cool. All right. Still having lots and lots and lots and lots and lots of errors. See this actually now there really doesn't need to be if it wasn't for the fact that the behavior is different, dereference local mute and dereference could be the same function. But yeah, there does have different behavior, doesn't it? So with it being that it's borrow mute, and then this add has to take well, that's just borrow, right? Incompatible types. Can't convert value to a ref cell. Eh? Oh, it is of value. Um, we don't need to borrow it. Borrow it in order to add to it. Actually, we don't need to borrow mute. We just borrow it. But is the problem the question mark thing? Because we'd return a result, self. Oh, we're assigning back into it. This should be borrow mute. Yeah. We'll borrow the value, add to it to construct something new, and then we reassign back in. Okay, I have to do the same kind of thing, don't I? This has to replace this. Actually, I just put a borrow mute in front. Okay. Okay, so this now gives me a shared data value. So I want to dereference that, right? No, I want to borrow it mutably. And then dereference it. Actually, if I don't, I do this, right? A reborrow. Yes. Okay. Oh, this is tough. I hate this. Loop init is a value. Loop variable is a shared thing. So, yeah, it's borrow mute. Okay, same thing here, right? We want to reborrow mutably. What? Oh. Yes. Please open the cell. This has got to like do a double borrow mute. So this doesn't actually need to be mutable. That can be immutable. And we need to dereference. Yep. It is an absolute nightmare. But that's what I inflicted upon myself by wanting to be able to share bits and pieces of a composite data structure. That's okay. I'm sorry you have to go through this nightmare with me. I'm not going to finish in time. I got a meeting in like 10 minutes. I think I just got to leave this where it is. Can I at least fix this? So here, a value. Yeah, so superset is a B tree, so I don't need to clone the value. I just need to share it, right? What's value? Oh. I do need to clone it, and then I need to share it. I'm starting to think though that all these cloning and sharing and borrowing, maybe I could have encapsulated that into some kind of handle object. Some kind of object that looks like it's owned, but really when you operate on it, it's actually doing an internal borrow. And like it's automatically dereferenceable as a component or a data value that's being shared. So that might be one refactoring I can do. But yeah, I'm out of time. I gotta rate someone. I'll be back tomorrow, I think. So I'm going to BlizzCon though. I don't know if I'll be streaming tomorrow. It might not be until it might be a while actually. I don't know when I'm going to stream next. which is bad because I'm in the middle of this like really bad refactoring. It's okay. We'll live. We'll survive. Let's rate someone who's working on Ruby and Rails. Shellcodes. Okay. Yes. Here we go. See you guys later. Thanks for sticking with me through this pain. I still don't even know if this is the right thing to do, but we'll find out. Bye-bye.